Man, I would like to say that I thoroughly underestimated the sheer complexity of building a computer from scratch. But after many hours of placing and wiring and godforsaken bug fixing, I have brought to you an update. First, let me show you the changes I've made to the computer layout plan. The instruction center has become the command center. It doesn't actually do anything different, I just felt it was a more fitting name. The program assembly has become the program selector. Same thing, just a name change. And the flipper has become the modifier. I changed it because instead of just flipping, it also lets you right shift. Right shifting is just moving every bit 1 to the right, which is effectively dividing the number by 2. It's pretty useful, but I won't be using it that much. And the last thing is the desktop program. Before, this was the audio processor, but for multiple reasons I've determined that it's just not practical anymore. As well as the fact that we're gonna need a desktop program to actually open the games. Now, there is something I want to go over before I show you all the new parts. This is the instruction list. The instructions that the CPU will read are composed of 16 bits split into 4 sections. These are basically functions that I'll be using to write programs with this computer. I'll only go over the first 5 instructions as they are the only ones relevant to this video. Instruction 0 is nil and does literally nothing. Instruction 1 is halt and it pauses the clock, stopping the program. Instruction 2 is load to register and it uploads a number straight into the register of choice. Instruction 3 is add to register, and it adds a number of choice to a register. Instruction 4 is subtract from register, and, well, you get the point. I also made a sheet that I'll be doing the program writing on, but that'll be for later once I show you the new components. This section right here is the clock. It sends consistent pulses to every single part of the computer while the program is running. By using just one clock for every single part, the entire computer is kept in sync. And because of the delay between circuit signals, the fastest I can make this clock pulse is 0.9 seconds. This could maybe change though, I'll go more into depth later. This here is the program counter. It holds a 6-bit number that counts up by 1 every time it's powered. This number represents which instruction the CPU is currently on. If that didn't make much sense, don't worry, I'll come back to this later. This right here is the instruction center, but it'll be looking a lot bigger than this later. It's practically the control center of the entire computer. When it receives instructions, it commands all of the parts of the CPU to achieve the function. This will eventually hold all 16 of the instructions that were on the instruction list, but right now it only has the 4 I went over before. This is the program storage. This is where I actually write the programs. This works on the same system as the data registry, the main difference being that each register is 16 bits, and that there's 4 sections, meaning this computer will hold 4 programs. Going back to the program counter, this 6-bit value plugs straight into the destination input for the program storage, meaning each stored instruction will be given to the instruction center for execution, and the program counter will move on to the next instruction. Now I'll show you the sheet where I write the programs. Using the instruction list as a schematic, I can manipulate the values in the data registry at will. This is the small program I wrote in the first slot of the program storage. It sets register 1 to 8, sets register 2 to 3, subtracts 1 from register 2, and then halts the program. Let's see it run in real time. Alright, this button right here is how I start the program. If I start the program here, we can see an 8 going to register 1, a 3 going to register 2, and then subtraction happening right here. And the program halts perfectly on step 4. I know, this program is boring and utterly useless, but it's about the concepts. Now that I can actually write programs, all I need is a display and I can actually start making games. But there is a sad, inevitable limitation to this computer. This is the tick speed of buildable logic gates. It may look fast, but when you chain 2, 4, 6, 8 of these things together, it starts looking a lot slower. This is the reason the clock interval is 0.9 seconds. I don't think the computer will function properly at any faster speeds. I haven't done much experimenting, so I could be very wrong about that interval, but the fact of the matter is these games are guaranteed to run very slowly. When I play them, I'll of course speed up the video, but it's a crippling limitation I thought I'd bring up. Now for some good news. I found that the best display method is pistons. I'll make a grid of pistons attached to latches so I can individually manipulate each pixel. We're this close to this mess of wires becoming an actual playable computer. Next time you see this thing, it'll be magnificent. You probably noticed in the data registry as well as the program storage that I only made as many registers as I needed. And that's because making more is, to say the least, tedious. Point is, next part's gonna take a little bit to come out because I can't put off making more data storage any longer. Please pray for my sanity. Okay, bye.